For example 5, this is brought up just because sometimes you take a look at something and you quickly want to be able to factor it, but it does help to actually check your work. So we're going to do a little mix of trying to guess what the factored polynomial is, and then we're going to check our answer so you can see some of the more common mistakes. So for A, you have x squared plus 9, and generally everybody looks at this and they're like, oh, it's kind of like a difference of squares. So that would be like x plus 3, but this is a positive 9, so that must just be x plus 3 times x plus 3, right? So this would be a very common mistake. However, if we go through and check, what is x times x? X squared. What is x times 3?
3x.
And then what
3x.
is 3 times x? And then 3 times 3.
9.
And then what do you notice?
6x.
So here we have a middle term. If you have two positive things, the difference of squares is nice because you would have like a positive 3x, a minus 3x, it would cancel out. But when they're both positive, you're going to end up with a middle term that's not going to be the same thing. So just a quick check of multiplying it out can kind of verify like, oh, that's not the answer, all right? So then this becomes irreducible. All right, so then we take a look at the second one. For B, there's probably 2 or 3 different common ways that people will try to factor this. So this is a really common one that people will factor, but if you took the time to check, you'd realize that it's not factorable. Can somebody give me an example of what they might try to say this is? Like, what would be your first instinct? Plus 2 plus 1. Very common, all right? Plus 2 plus 1, because they're like, oh, well, 2 and 1 is 3. 2 times 1 is 3. You're kind of thinking that way, but when you multiply it out, you get x squared plus 1x plus 2x plus 2. So then what's happening is your terms are flip-flopped. We're getting 3x for the middle term, but we're only getting a 2 for our third term, our constant term, okay? So that doesn't work. Sometimes I'll see in here for this one like x plus 3 times quantity x minus 1, but then you're forgetting like, oh, that would give you a negative 3 for that third term, okay? So just kind of going through your checking stuff, we also will find then that this is irreducible. For example 6, I kind of feel like B is a lot simpler, so let's go ahead and just start with that one. For part B, if we were to group these, what would be one possibility of grouping them together so we can factor out GCFs? Yeah, so we would if you're gonna group the AY squared, the BY squared, so that would be 1, and then what would be our leftover grouping? AX plus BX. All right, so this is definitely one way you can do it. So if we have this and we group the first two, what do they have in common? Y squared, and what's left over? A plus B. And then for this group, what can we pull out?
X.
An X. What's left over? A plus B. And then we see we have our common binomial, so we can pull that guy out. And then what's left over? Y squared plus what? Plus X. Good. All right, so that's one way. All right, same problem. So that's option 1. Same problem. We could have actually left this. Oops. We could have actually left it like this, and I know this is kind of messy here. What is in common in the first two? A, and we pull that out and we're left with what? X plus Y squared. And what can we pull out of the second set? B, what's left over? X plus Y squared. So now we have our common binomial. We pull out the X plus Y squared, and then we're left with A plus B, okay? So for this example, there are 2 ways will both get you there. This is a more ideal way of grouping because you can do it in multiple ways and come up with the same answer. All right. For A, 6A, this one's a lot more difficult, all right, because this is a kind of grouping that you guys aren't kind of used to. So you guys don't need to write this down, but I will let you know at first glance, this is how most people are going to try to factor this. They're going to group the first two because it's a difference of squares, and they're going to group the second two. And what's nice is they both actually do factor. For this first one, you get x plus y, x minus y, and then plus. And then for the second one, we can pull out a 5, and we get x, 2x plus 5. Okay, now what is the issue with grouping this way? Right, we still need to keep factoring. This isn't factored. Notice we have one term, so we have a product plus a product. This isn't done factoring. When you are done factoring, notice you're multiplying. We have a monomial times a binomial times a binomial. Monomial, binomial, binomial, binomial. Binomial times binomial. Binomial times binomial. Binomial times binomial, and so on. Do you see what I'm saying? I know I pointed up here and nobody told me you couldn't see it, but the idea is everything's multiplied. So if this is what we have, this isn't factored because we have a binomial times a binomial plus a monomial times a binomial. If you're adding, then you have two terms, like completely different terms, and that's not factored. If something's factored, it's only a product. All right? Well, nothing is in common here that we can pull out, so we cannot factor this by grouping the first two and the second two together. So we have to find another way. Okay? I want you guys to take a look at it. Can anybody come up with a different way that we could do this? Yeah. Oh, so close. X squared plus 10x. Let's take a look at what you were saying, though. I do want to write that. So x squared plus 10x minus y squared plus 25. So we could factor out the x's here. And here, this would be like a difference of squares. It would be like y plus 5, negative y plus 5. But again, we're running into the same mistake, right? Does everybody see that? Like, we don't have a common thing to factor out of both terms. So this is our first product plus our second product. We don't have anything in common. This is the right start. What's the next number going to be? Plus 25 and then minus y squared. This is a really tricky problem because you're actually going to group a trinomial with a monomial. It's different. It's extra challenging. You know, if we made everything easy for you guys, it wouldn't be fun, right? So, what is this when you factor it?
Is it x plus 5,
X plus 5, x plus 5 minus y squared. But x plus 5, we actually have another way to rewrite that. Do you guys know how? X plus 5 quantity squared minus y squared. Uh-oh. What do you guys notice you have? One person mumbled it. What is this?
A binomial, a trinomial. I don't know.
This is a binomial squared
Minus a
monomial. So it's a difference of squares, just like the first one.
Oh,
Binomial squared minus a monomial squared. So what is the square root of x plus 5 quantity squared? X plus 5 and x plus 5. What is the square root of y squared?
Minus y plus 5.
So we have plus, we have minus, and voila. Good? Everyone good? Questions? Okay. I'm going to squeeze in this last example. All right. So, for example, you guys, for example 7, you guys are going to be using something called SOP. SOP. And what this is same, opposite, positive. Okay, some people will say soap, and they'll say same, opposite, always positive. Right, is another way. Some people will just say sop. I say son of a Pearson after the guy that taught me this method. His name was Pearson. So you guys got to figure out your own way to remember SOP, but do remember that because when you have sums and differences of cubes, there actually isn't a very pretty or easy way to do it, and this is one of the most helpful things in trying to get there. All right, so same, opposite, positive. This deals with the signs that you are going to be putting into a binomial times a trinomial, which will multiply to your sum and difference of cubes, okay? So here's what we're going to do next. We have t cubed minus 125. You're going to ignore that minus because we're going to use this for that. You're going to purely look at the number values, and you are going to take the cube root of them. So what is the cube root of t cubed? Cube root of it is just t. So we have t, t, t. What is the cube root of 125? 5, 5, 5. All right, and what you're going to do, you're going to make a binomial space, and you're going to make a trinomial space, and now we can use that SOP. All right, so the sign here is minus. So the first thing is same. What is the same as a minus sign? Minus. And then the next one is opposite. What is the opposite? And then the last one is always positive, okay? In the binomial, you are going to put the perfect cubes. So you are going to put t and 5. In the trinomial, you are going to put in the products of these 3 circles here. So you're going to take these values and you're going to pair them up. T times t is, t times 5 is 5t, and 5 times 5 is 25, done. See how that worked? All right, so let's do the same thing here. Cube root of 8. 2, 2, 2. Cube root of 27a cubed. 3a, 3a, 3a. You're going to circle the pairs. And then you're going to set up your binomial times your trinomial. So we have a binomial. We have a trinomial, and we already know the signs. This is a positive sign, so in here I'm going to have positive, negative, positive. Is everybody okay with how to get these signs? Okay? And what goes in the binomial? 2 and 3a, so you're just putting your perfect cubes. And then in the trinomial, we're putting the products in each of our paired circles here. So 2 times 2 is?
4.
2 times 3a is?
6a.
And then 3a times 3a is?
9a
9a squared. And now you have your factored sum of cube here.
Yay.
Mm-hmm.
Okay.